All right, in this video, we're going to take a look at prime factorization. So make sure you put today's date in the upper right-hand corner of your notebooks. So when we prime factor, what that means is that we are going to factor a number down to its prime factors. A lot of times you'll see this, you'll use what's called a factor tree. So the best way to look at this is look at some examples. All right, so let's say I asked you to factor 80 down to prime factors. So you have to think back to the divisibility rules and think about numbers that are even, numbers that can be divided by 5, numbers that can be divided by 10. Right away I can tell this number is even, so I can automatically divide it by a 2. So I'm going to list the factors of 80 that have 2 in them. So 80 divided by 2, so it's going to be 2 times something. So to find that out, I'll just use my calculator. 80 divided by 2, we get 40. So 40 times 2 is 80. So we just factored that into 2 factors. But I want to keep going. So 2 is a prime number, so I can't factor that any further. But I can still divide 40, or split that up, because 40 is not a prime number. So again, that's an even number, so I can divide it by 2, and that'd be 2 times 20. So then I repeat again, another even number, 2 times 10, and then I repeat again, 2 times 5. So I just factored 80 down to its prime numbers. So what I see here is that 80 is the product of 2 times 2 times 2 times 2 times 5. Those are the prime factors of 80, because I can't break down 2 any further and I can't break down 5 any further. When you do prime factorization, you don't write 1 times a number. So that means only prime numbers should be at the end of your trees. And then using properties of exponents, I've got 4 2's, so it's going to be 2 to the 4th times 5. So this comes up later in other types of math that you're doing when you're trying to factor things out. It also comes up a lot when you're working with simplifying radicals and looking for perfect squares in a number. It's also good just to know your factors of your numbers. All right, let's try another example. Let's try 100. So my divisibility rules, remembered, any number that's even can be divided by 2. For 4, we just see if that number is a multiple of 4. 5, it has to end in 0 or 5, and 10, it has to end in 0. So since this number ends in 0, I know that a multiple of 100 is 10, or factor of 100 is 10. So let me use my calculator again. If I take 100 divided by 10, I get 10, because that means 10 times 10 is 100. But now I haven't completely factored this because these are still not prime numbers. 10 can be written in other ways than 1 times 10. And the other way to write 10 would be 2 times 5. So this means that 2 times 2 times 5 times 5 gives me 100. Or 2 squared times 5 squared. That's the same concept. Now there's lots of ways to factor 100. You might have done it a different way. Maybe you started off with 2 and 50 or 4 and 25. Either way, you're going to end up with the same result. That's the beauty of prime factorization. There's multiple ways to get there, but you get the same answer at the end. Let's take a look at 2 more examples to try. Let's figure out, how can I factor 45 down to its prime factors? So remember, go through your rules in your head. If it's an even number, you can divide it by 2. So this one I can't divide by 2. That's an odd number. I can try factoring it by 3. So if we use our calculator, you take 45 divided by 3 and see if that gives you a nice whole number, and it does. So that means 3 times 15 is 45. I know 3 is a prime number because there's no other way to get 3 other than 3 times 1, but I can factor down 15. That ends in a 5, so I know I can divide it by 3 or by 5, and 15 divided by 5 is 3. So the prime factorization of 45 is 3 times 3 times 5. I'm just writing down the numbers that don't have branches underneath them. So the form with exponents is 3 to the second power times 5, or 3 squared times 5. Let's do one more example. Let's factor 36. So I see that 36 is even, so I'm going to divide that by 2. So 36 divided by 2 is 18. So 2 times 18 is 36. I can factor 18 down. There's a couple ways to get 18. I can divide by 2. I could divide by 3. I'm going to divide by 3 because I know that 3 times 6 is 18. So again, I'm just picking the numbers that are composite to keep building branches off of. So these are 2 prime numbers here. 6, I can multiply together 3 times 2 to get 6. So now I've got my prime factors for 36. I've got 2 2s, so 2 times 2, and 3 3s, so 3 times 3. So remember, your factors, your prime factors, are the ones that are at the end of your branches that can't be broken down any further. So the final answer with exponents, which is prime factorization using exponents, is 2 squared times 3 squared. And that's factoring down a number down to its prime numbers. We're going to use this to help us out when we do least common multiples and greatest common factors as well. So why don't you get some practice with your prime factorization.